For years, we were pretty sure we'd cracked one of the biggest mysteries in our solar system, that Saturn's giant moon, Titan, is hiding a huge ocean of liquid water. But what if the truth isn't that simple? What if all the evidence is pointing to something, well, a whole lot slushier?
That question, it's pretty much the driving force behind all of planetary exploration. We're on the hunt for liquid water because, as you know, where we find water, we just might find life. And that search has taken us to some seriously unexpected places.
And you know what's wild? The Saturn system has turned out to be a total hotspot for these potential ocean worlds. We've really zeroed in on a couple of prime suspects, the enormous hazy moon Titan and its smaller, way more hyperactive sibling, Enceladus.
Take Enceladus. This little moon absolutely blew our minds when we found out it was literally spraying geysers of water and organic stuff right out into space from its south pole. But as cool as moons like Enceladus and Tethys are, it's the colossal Titan that holds the most Earth-like and yet most alien mysteries.
Okay, so to crack a case this big, you need a top-notch detective. And our detective was the Cassini-Huygens mission. This was an incredible international team-up between NASA, the European Space Agency, and the Italian Space Agency. It was basically our robotic eyewitness out at Saturn for more than a decade. And let me tell you, this mission's journey was absolutely epic. It launched way back in 1997 and took 7 years just to get to Saturn. Then for the next 13 years, Cassini did laps around the ring planet, while its little partner, the Huygens Probe, made the first ever landing on a world in the outer solar system. We're talking a 20-year saga of pure discovery.
So what did our detective find on Titan? Honestly, it was revolutionary. Cassini peered through that thick, orange, hazy atmosphere and found a world that felt hauntingly familiar. It's got lakes and seas, sure, but they're filled with liquid methane. It's got deserts with massive dunes, but the sand is made of frozen hydrocarbon bits. It even has a weather cycle, but instead of water, you've got methane rain. Scientists call it an alkanological cycle. And, most important of all, Cassini found complex organic molecules, the very stuff life is made of.
But the real headline grabber, the discovery that put Titan on the map as a top contender for extraterrestrial life, was the evidence for a gigantic, global ocean of salty liquid water just sloshing around deep under its icy surface. And for years, that was it. Case closed, right? That was the scientific consensus. But like in any great detective story, just when you think you've got it all figured out, there's a twist. A fresh look at some old evidence was about to turn this whole case right on its head. And this, my friends, is where science gets really cool. See, years after the Cassini mission ended, scientists had way better computers and much more sophisticated models. So they went back, dusted off the old data from Cassini, took a closer look, and a new, much weirder picture of what's inside Titan started to take shape.
The smoking gun was this one tiny, weird anomaly in the data, a 15-hour delay. You see, Saturn's gravity is so massive that it constantly pulls and squeezes on Titan, changing its shape. But scientists found that Titan's bulge lags behind that pull by 15 hours. It's kind of like if you push a swing, but the swing is always a little bit late in its movement. That delay, that was the clue.
Now, that lag, it just doesn't work if you have a big, sloshy, liquid ocean. Water isn't sticky enough to cause that kind of delay. But you know what does work? A thick, slushy interior. Yeah, think less like an ocean and more like a planet-sized slushy, a really thick, goopy mix of ice and water. The stickier material would resist Saturn's pull, creating the exact time lag they saw in the data.
So, wow, this changes everything. Which brings us to a brand new, fascinating question. Could a slushy world actually support life?
One of the scientists on the new study, Baptiste Charnoz, put it perfectly. He said, we need to shift our whole perspective. We're not looking for a big open ocean on Titan anymore. What we're probably looking at is something much more like the Arctic sea ice here on Earth, or maybe underground aquifers, these pockets of water trapped inside a giant icy slush.
So, okay, does slushy just mean lifeless? You think so, right? Well, get this. The answer might be the complete opposite. Believe it or not, this new slushy model could actually make Titan more habitable, not less. Here's why. Instead of nutrients being all diluted in one giant ocean, they'd be super concentrated in smaller, separate pockets of water. These little pockets could also get surprisingly warm. Some models suggest they could reach a comfortable 68 degrees Fahrenheit or 20 Celsius. This creates tons of unique little microenvironments, a lot like the ones that support life in the icy parts of our own planet.
So, Cassini's amazing mission is over, but its legacy? Well, its legacy is a whole new set of questions that are just begging for a follow-up investigation. The case of what's inside Titan is far from closed.
This new model just blows the doors open on what we need to find out next. To really understand Titan, we're going to need a whole new generation of tools. We'll need advanced radar that can actually see through the ice, better spectrometers to figure out what's really in the air, and maybe, just maybe, a lander that could one day splash down in one of those methane seas. Each mystery needs a new piece of tech to solve it.
And the really exciting part? The first of these follow-up missions is already in the works. NASA is sending a literal nuclear-powered quadcopter drone called Dragonfly. It's set to launch in 2028, and it will fly around Titan's atmosphere, landing in different spots to study its chemistry. It is an incredibly ambitious mission, and it's going to give us the next huge piece of this puzzle.
So here we are. We've traded this clean, simple idea of a global ocean for a messy, complicated, slushy reality. But somewhere in that slush, in those hidden pockets of warmer water, might lie the most profound secret of them all. The investigation, as they say, continues.